I'm full of it. No, just kidding. I already did some of that work that we just talked about. Welcome back to the lab, by the way. You're watching EE for Everyone. We are in the next spot of our UPS project. This video is meant to come out a long time in the future, but life happens, things get expedited, and we have a fully built UPS mainboard complete with Atmel Micro, Ethernet PHY, power supplies, and PCIe cards. And we also have a battery daughter card. So this should be capable of charging batteries, keeping the 24 volts active after the supply fails, and yeah, I lost my train of thought. But anyways, fully functional, hopefully, battery daughter card, and that, my dear friends, is what we are going to investigate today. Wow. This top view camera cannot see enough. Let's fix that. Let's put on a different lens. Okay, that is much better. So, we have the battery module. This is featuring a basically an Arduino Uno, a couple logic translators, TL594 for the switch power supply. Control, we've got some chunky 1200 volt rectifier diodes, 7 microfarad, 650 volt rated output caps, a couple custom inductors, and one custom transformer. This is a 1 to 7 transformer that has 2 secondary taps in series, which allows for our split thingy in the chassis, our split DC bus. Can you tell I'm in a little bit of a hurry? No, I'm sure you can't. We'll get to that later. But there we go. Got it seated, secured. Had to take the front panel off the case in order to fit it in there. Well, actually, to be honest, looks like the front panel might fit. But I did need to remove the metal. Now, while this thing's beeping and annoying us all, I want to take a moment to tell you something very, very important. Never, ever, ever rush. Because when you rush, you do stupid things and you blow up hardware. You hear? Never, ever, ever rush. I am in a hurry. I might rush a little bit. If this blows up, I'm going to be a little disappointed. Let's go. Okay, that buzzing that you're hearing is because we currently have both supplies enabled. We've got the battery charger and the 24 volt backup supply both running. That is the current problem. I think I need to hard power cycle this thing. The Arduino dude doesn't like our power on reset circuitry, so whenever it gets hung up, I think it's kind of particular about how it's reset. Anyways, we're getting in. I'm going to use the reset button to cycle through the display. I don't think you can see that. Okay, I'm going to get the power thing off to the side so we can see this display. And I'm going to cycle through to daughter card 1. Okay, so you can see the voltage output is measured as 24 volts. What is the output voltage really? It's really 21.9. That's okay. We're reading a little high. Power output is negative 18 watts. That's a little weird. Let's see. Why is that FET so hot? Whoa. Oh, it's because we're undervolting the input. I need to not be doing that. Okay. Different power supply. Different story. Ooh, that guy was getting hot. We're at 32 volts, we're bringing her down 24. There we go. Now that we've got the proper... Okay, the issue is that we were undervolting the input, so we actually had a couple converters fighting. Now that we don't have a couple converters fighting, we're at 50 volts on the output. Let's click through the menus, see how that measures. It says voltage out is 54 volts. That is fine. Close enough. And I'm guessing that's because our reference voltage is just a touch low. We are right on target. And now I gotta test this. Yeah. So our output voltage is exactly correct. We're at 54 volts. And if I heat up the output, we should see the thing. Whoa, whoa, whoa. That just turned on the fan. This is reacting like a normal thing. Wait a minute, wait a minute, wait a minute. No way. No way. Just gonna cool off the board. In fact, let's strap it to the heatsink. Yeah, the fan kicked off. Okay, so now if I heat up the board, the fan will kick on. And eventually, oh look at that, yeah, the output voltage dropped. The output voltage dropped. Oh, that is so cool. Okay. Not sure if you could really catch that. Yeah, I think you could. That is incredible. And as we crank up the output current, we can see that it kind of falls out of regulation. But this just might work. So here's what we're gonna do. Okay, batteries acquired. Here's what we got. We got a DMM monitoring charge current. Right now we're getting 50 milliamps. The voltage output is quite accurate. It reads 55 volts on the microcontroller. Batteries are reading 5133. Okay, maybe it's not perfectly accurate. That's okay. So here's where things are going to get a little nuts. Basically, if I keep the DMM somewhere kinda visible, let's try that. It's visible on the side camera. And we go ahead, put on these nice little voltage clips here. By the way, I know heatsink clips are required to make sure we have adequate thermal contact. However, we've got clips for TO247s, not for TO220s, and they don't hit the part at the right spot. So we're just not going to load the thing, and it'll be okay. Okay. So then in order to actually evaluate the high voltage bus, we now have our multimeter hooked up to the bus. And if I hit the go button, it should. I have this thing set up basically with a dead man switch. So if I hold the power button, we should kick on the downstream regulators. That sounds fine. I guess I'm gonna plug my ears in case this explodes. Hold on to your hats, 'cause here we go. Look at that. 250 volts DC. I think that's even what it's designed for. 248.8. Uh-oh. Dead man switch isn't working. Uh-oh. Dead man switch isn't working. We're about to try a pretty terrifying test. You might notice a different kind of pace today. Well, equally scary, different kind of vibe. So, yeah, we just left off where we know that our battery daughter card can make 250 volts DC. Our inverter daughter card is now installed. We've tested it at 30 volts DC. Oh my goodness, it might just explode. But hey, we're not gonna know until we hit the button and see what happens. So, with 2 daughter cards installed, battery module at the ready. Yeah, we're gonna pull out the 24 volt input, so we've got a single way to remove power. We're having a bit of an issue where the main board will glitch out, where whenever we enable the daughter cards, there's enough noise coupled back into the low voltage DC side that it seems to be triggering the reset somehow on our, basically the Arduino Mega equivalent. Yeah, it's not great. It's been kind of glitchy, which is weird because it's got its own like core voltage regulator and it just seems to be not working great. Like it regulates its own V core, like a 1.8 volt. So I don't know what's really going on there, but that's okay. So basically what we've got is we've got the DMM that is currently monitoring the output voltage in volts RMS AC. And we've got one big power button to push that should turn it all on. I'm gonna kind of look away and hit the power button, and we're gonna see what happens. Okay, that turned off in a hurry. There was a flash, and then it was dead. Interesting. Interesting. Do I dare try to boot it up again? I think I do. Okay. Whoa, there's some smoke. Ooh. Yep, there's some smoke. What is that coming from? It was one of the 2 daughter cards. Okay, I'm gonna check the voltage over here. Okay, looks like the battery charger might have died. Something's getting hot. Ooh, got a gate driver getting hot.